Imagine you're an astrophysicist staring into the cosmos through the lens of the most advanced space telescope on Earth. What you observe is not only filtered through the lens of magnificent technology, but also your own perception. Of course, if you're an astrophysicist, your perception, shaped by your education and training, tells you that gravity, and gravity alone, governs the universe. And yet, stupendous electromagnetic phenomena routinely explode into astrophysicists' awareness, with no regard for human interpretation. So how does one explain an undeniably electromagnetic phenomenon in a universe where electromagnetism is not thought to be the cause of anything? All too often, the answer is either very poorly or not at all. And the root of the problem has no hope of being identified if the underlying assumption of an electrically neutral cosmos remains unchallenged. The recent discovery I'll now share cannot highlight this point any more clearly. The gamma-ray burst is the most energetic electromagnetic phenomenon known to science. A so-called long-duration gamma-ray burst, which should only last about 2 seconds, is thought to occur due to the core collapse of a black hole during a supernova, which then forms astrophysical jets that emit gamma rays. Short-duration gamma-ray bursts are thought to be caused by the collision and merger of objects such as neutron stars and black holes. In either case, it is a gravitational process that is thought to ultimately drive the electromagnetic displays. However, scientists have recently observed a gamma-ray burst which gravitational theory simply cannot explain. As described in a recent Science Alert report, entitled "Astronomers Just Saw a Gamma-Ray Explosion Defy All Known Space Logic," a giant explosion that lit up the sky didn't just rock the cosmos, it absolutely rattled our understanding of the universe's most powerful outbursts. The gamma-ray burst, recorded on July 2, 2025, is the longest of its kind ever observed, lasting about a day. By comparison, gamma-ray bursts normally last on the scale of milliseconds to minutes at most. Moreover, it did something astronomers have never seen a gamma-ray burst do before. It appears to have repeated. This can't be neatly explained by our current models for what causes them. Astrophysicist Antonio Martin Carrillo stated, "This event is unlike any other seen in 50 years of gamma-ray burst observations. Gamma-ray bursts are catastrophic events, so they are expected to go off just once, because the source that produced them does not survive the dramatic explosion. This event baffled us, not only because it showed repeated powerful activity, but also because it seemed to be periodic, which has never been seen before." And herein lies the heart of the still unfolding crisis in cosmology. The theoretical toolkit of gravity-centric astrophysics does not include a causative role for any electromagnetic mechanisms, no matter how well documented they are by plasma scientists. Explosions, collisions, mergers, gravitational collapse. This is the terminology of scientists attempting to explain cosmic electrical discharges through strictly mechanical processes. Now, back in 2014, I reported on another long-duration gamma-ray burst which appeared to originate just 3.8 billion light-years from Earth, and which lasted for 20 hours. This was considered anomalous not only because of its remarkable duration, but also because most gamma-ray bursts have long been thought to originate in the so-called early universe. One investigator, Charles Dermer of Los Alamos National Laboratories, said at the time, "Some of our theories are just going down the drain." Here's a clip of my interview with Wal Thornhill on this topic, in which Wal summarizes why the electrical model of stars and supernovae can explain many of the mysteries surrounding gamma-ray bursts.
The standard model of a gamma-ray burst has all of the activity centered on a star, or the collapse of a star, which means that whatever happens very quickly, and the energy is released normally within about 30 seconds. However, the electric universe model has the star connected to a circuit which is gigantic compared to the size of the star. In fact, the star itself at the center of this circuit is like a speck of dust. The circuits that feed a star can be seen in planetary nebulae. The star appears as a bright point at the neck of the hourglass. Now, when a discharge to a star reaches a certain current density, it is possible for that current to be suddenly shut off, as if a switch is thrown. A good example of the sudden closing or opening of a circuit which carries a vast amount of power can be seen on Earth, where the high voltage transmission lines reach a switch yard, and when those switches are thrown, you can see a discharge which lasts for seconds, and a lot of energy, a lot of radiant energy is emitted in that process. Now, if you scale that up to a stellar size, of course, that discharge can last for hours. In this case, it may be that we were peering down the barrel of the hourglass, if you like, and the switch was thrown somewhere in the neck of that hourglass, and then the ripples continued for 20 hours afterwards. The fact that most gamma-ray bursts appear to be of short duration, maybe only 30 seconds or so, may be due to the fact that we're looking at the hourglass, if you like, side on. It seems possible that looking down the barrel of that hourglass, the radiant energy from that outburst will be concentrated and pointed towards us over an extended period of time. The standard model of a gamma-ray burst has no way of explaining a 20-hour radiant output from a collapsing star.
Now returning to the recent gamma-ray burst, which has sent astronomers scrambling for an explanation. Again, what makes it so problematic is not just its long duration, but also the fact that it actually repeated. This brings to mind another spectacular electromagnetic phenomenon, called a pulsar. Mainstream astrophysics tells us that a massively dense, yet tiny object, a dead star called a neutron star, produces the electromagnetic pulses detected on Earth by mechanically spinning like a lighthouse. However, 30 years ago, Drs. Anthony Peratt and Kevin Healy produced a model based on plasma physics which explains the properties of a pulsar with no neutron star. Rather, they propose that pulsars are essentially electrical oscillations occurring between a normal star and a disk of matter about the star. We need to consider the remarkable number of so-called neutron stars that behave impossibly. This includes pulsars whose signal is so rapid, they would require a neutron star to spin at about a quarter the speed of light. It also includes neutron stars that appear to shine so brightly, they shatter the theoretical limits of an object's luminosity. In other words, astrophysicists have more than adequate incentive to consider a promising theoretical alternative, such as the Peratt-Healy model. Now let's consider the following observation about this latest impossible gamma-ray burst. The following passage from the Science Alert report is especially interesting. The unusual nature of this new detection was obvious immediately. It was discovered from alerts delivered by NASA's space-based Fermi Gamma-Ray Telescope, not just once, but 3 separate times over the course of several hours, as the object seemed to pulsate in multiple repeated bursts of gamma rays. Checking other telescope data revealed that the Einstein probe, a space-based X-ray observatory, showed the same source had been sending out X-rays almost a full day before the Fermi observations. It was so bright that astronomers initially thought that the source was right here in the Milky Way. However, when they trained the Very Large Telescope and the Hubble Space Telescope to the spot in the sky where it came from, they discovered otherwise. It's unclear how far away it is, but the progenitor of the weird event is also weird. A galaxy with a very strange shape, appearing to be split into 2 distinct regions. This could be a clue about what produces the explosions, but at the moment, it's still one heck of a mystery. I think this sentence reveals the underlying cause of the ongoing mysterious nature of gamma-ray bursts and many other stupendous electrical phenomena in the cosmos. The author refers to the baffling, periodic, long-duration electromagnetic emissions as, quote, explosions. But mechanical explosions explain nothing about the actual observed phenomenon, which the investigators themselves acknowledge. Consider now the image on your screen, a particle and cell simulation by Dr. Anthony Peratt showing twin Birkeland current filaments taking on the form of a spiral galaxy. Indeed, for well over half a century, plasma cosmologists have been producing the structure and motions of galaxies in laboratory experiments with electrical discharge. In plasma cosmology, like the formation of stars, galaxy formation is far more rapid when electromagnetism is the governing force rather than gravity. Note again that the apparent progenitor of the baffling gamma-ray bursts we're discussing is a strangely shaped galaxy that is split into two parts. I can't claim to know the answer to this question, but I wonder, could this galaxy be in the final stages of its electromagnetic formation? I'll note that investigators remark in their scientific paper that the redshift of the galaxy is not currently known. However, the electric universe subscribes to Halton Arp's thesis that cosmological redshift is intrinsic and is not an indicator of an object's distance from Earth, and that in fact, high redshift indicates an object's youthfulness. So I'm eager to learn more about this galaxy over time, given its potential promise for the EU and plasma cosmology. I'll remind viewers that I'm a layperson, and I've always avoided offering my own unvetted opinions on these matters. So I'll leave you with the familiar voice of our good friend and teacher Wal Thornhill, as he outlines a missing theoretical element at the heart of cosmology.
It was Hans Alfvén, the Nobel Prize winner in plasma physics and also the father of plasma cosmology, who pointed out decades ago that astronomers were missing something basic in the form of what he called double layers, electrical double layers, which are formed when electric current flows through a plasma. He said that these double layers should be classified as interstellar objects and intergalactic objects because they radiate energy rather like a star can, and they radiate radio noise. In other words, they are the sources of high energy radiation. But since astronomers have ignored what Alfvén had to say when he pointed out that their theories of plasma physics and what's going on in space is incorrect, the theories that the astronomers have restricted themselves to are now struggling, and the anomalies are coming in.
Thank you.